Today we're going to cover controlled experiments. I'm going to start off by giving you an example of one that's not a controlled experiment. So Emily wants to perform an experiment to see what conditions make a plant grow the tallest. So she buys 3 different plants and takes care of them according to the chart below. So for the types of plants, she has a spider, a pothos, and an aloe. And then for light, you can see she gives them 8 hours of sun a day for each. But for food, she gives them a different amount, each of them a different amount. And for water, she also gives each of them a different amount. So if at the end of this experiment, the pothos plant is the tallest, you don't know if it's because the pothos plant just grows at a faster rate. Is it because of the food? Is it because of the amount of water it got? The problem with this is that there is too many variables. You are only allowed to have one variable in an experiment. And that kind of experiment is called a controlled experiment. There are other kinds of experiments, but a controlled experiment is the one that we're going to talk about. So a controlled experiment, the definition is a test of a hypothesis under conditions established by the scientist. It doesn't really give a whole lot of information, but hopefully it'll make more sense by the end. Okay, so variables. Variables are all the different things that you can change in an experiment, but you're only allowed to change one of them at a time. You have to control all the rest of the variables by keeping them all the same. The only one that you change is the one that's called the independent variable. So the independent variable is the one that you change in an experiment. The dependent variable is the one that changes because of the independent variable. And I never really liked that definition. I've always thought of it's the one that you measure. Whatever it is that you're measuring when the experiment is over, that is your dependent variable, whatever it is that you measure. So the control group is the one that doesn't have the variable that you're changing. Now, right now, those might not all make a whole lot of sense, but hopefully it will by the end. Okay, so a scientist wants to know which brand of fertilizer will cause her tomato plants to produce the most tomatoes. She has 3 different brands of fertilizer. How should she design her experiment to test the 3 fertilizers? So number 1 says, name the things you need to control in this experiment. And if we were in class, people would be volunteering and coming up with these, but we don't have that option here now. So the things that you would control in this experiment is you need to have the same kind of container. They all have to be in the same container. You have to give them the same kind of soil and the same amount of soil. You need to get the same amount of water each day, the same amount of sunlight, and the same amount of fertilizer. I also should have said it's the same type of plant. You can't change the plant type. You can't have 2 different types of tomato plants, or 3 or 4 different types of tomato plants, however many you're testing here. So the independent variable is the thing that you change. So if you look back up on the top, what she's testing is the different brands of fertilizers. So your independent variable is types of fertilizers. The dependent variable is, again, it's what you measure. So what are we measuring here? They're looking at which one produces the most tomatoes. So the thing that we're going to be measuring or counting is the number of tomatoes. Okay, so independent variable is the one that you change. That's the fertilizer. The dependent variable is the thing that you measure. It's the number of tomatoes. So an experiment might look something like this. So I might have a control group. Maybe that's the first one. And then that one does not get any fertilizer, so no fertilizer. And then we might have, this one is test A, test B, and test C. So these might be fertilizer A, fertilizer B, and fertilizer A, fertilizer B, and fertilizer C. So all of these 3 plants here are getting fertilizer, but all 4 of these plants are all getting they're the same pot, the same type of plant, the same soil, sunlight, water, all of those things have to be the same. So at the end of this, because everything else has been the same, if B ends up with the most tomatoes, then we would assume that B was the better fertilizer. Now, there's other factors involved, and I would say that just testing one plant of each isn't enough. I'd probably have maybe 10 plants each, and then kind of get an average for the number of tomatoes. I think that would make a much better experiment than basing it on a single plant. But again, that's something that if we were really doing it, I would prefer that it would be set up with a bunch of plants. But hopefully that makes what a independent, dependent variable and the control group are.